Okay, so this is part 2 of the video tutorial. In this video I'm going to talk a little bit about the code and how it works and sort of get you up to speed on how to sort of get this thing actually running on your computer if it's not working and finding out how to figure out how to connect all the things that you need to connect. Okay, so the goal of this program is to draw these pretty graphs and then draw these little dots. And so what these dots are doing is that they're basically representing a musical path over time. Each circle represents a note. Its color represents its pitch. The distance between circles is sort of how long each note has space, or it's like the rhythms that we're going to develop. So, a longer line means there's going to be more time between the notes being played. The branch width, so this line width here you can see is different. So the wider line means there's a higher probability we'll take that branch. The skinnier line means we'll have a lower probability taking that branch. And that's it basically. It's all there. So we've got this thing going. Let's hear what it actually sounds like. Let's hear what this thing can do for a second, and then we'll talk about how to make it different, better. Okay, so as you can see, it's going through. It's developing, these rhythms that are happening. The rhythms are happening as a function of the different notes that it's going through. There seems to be some structure here, but there's also this idea of randomness. And so this is really the idea I was getting at in terms of stochastic tree sequencer. The idea was, electronic musicians often get accused of just making a bunch of beeps and boops. Often that's kind of true. And so if we can bring a little bit of structure into our randomization, that's when we get some really interesting and creative ideas going. So that's the goal of this thing. It's like, how do we bring some structure to randomness, still allowing randomness and all the coolness that implies to happen, but bringing in that structure to give our brain something to latch on to. So it's not just a bunch of noise. There's a pattern or a rhythm that we're going to try to figure out. That's really the opportunity is here. So there we go. That's what the stochastic tree sequencer is doing. So basically, as each note gets passed, each one of these circles gets passed, a MIDI message gets sent from this interface over to our sequencer or our synthesizer. So here's our synthesizer over here. You can see again the keys down here lighting up as it happens. And if I turn up the volume, Cool. So there it is. There is stuff happening, sequencers making sounds, stuff connected. And so again, MIDI messages are getting sent from here to our sequencer. The synthesizer is making sounds, and we're making music, which is cool. Okay, in this interface, the other thing you're going to see are two things. There is the update button. So clicking the update button is going to reset the map and create a different set of rhythms and notes and probabilities for all these things. Basically changing, what's happening. You can click that and update it as much as you want. And we're going to get different structures of rhythms and notes and all of that kind of stuff, and melodies then. The other thing you're going to see on the screen is this big message down here, using IAC driver IAC bus 1. This is important. This is what makes all the magic happen. And so in the last video, we showed you how to set up a virtual MIDI bus. We need to have that name that you were using selected here. And then in your synthesizer, this program you downloaded at Helm, you need to click on the helmet and make sure that MIDI bus is named here and selected. The yellow square means selected. And so what this is going to do is make the sound come out, basically, because we're going to say, take these messages from the output of this, use the IAC driver IAC bus 1, or whatever yours is named, and then receive those messages over here on Helm saying receive messages from this bus and turn them into sounds. One other thing in Helm to know, clicking that helmet is a nice little thing to do. There's lots of different output devices. I clicked a multi-output device because I'm doing something weird with my setup to be able to record the sounds. But usually you want to have your built-in output as a default, unless you know which specific sound card or speakers you want to use. So I've got multi-output device, but you might have something different listed there. So click the helmet. That's how we get to that menu. You make sure your MIDI bus is active. And so theoretically, if you have these two things going, you should have some sounds being created. which is kind of cool. Okay, so sounds are created, stuff's working. How does the code work to make all of this happen? Well, it's really simple. It's not a super complicated sort of set of code. But before we get there, I want to show you one last thing while we're on this page. On a web browser, if you right-click in Chrome, you should get an option to click Inspect. Inspect is going to pull up sort of this background information that's happening about the website. In the Inspect option, there's a thing called the console. So I'm going to click Console, and you're going to see messages that show up here. Hopefully, you have got two things that have shown up, at least two things. The first one's going to be a warning. Don't worry about this warning. This warning is just a standard thing, talking about the library being outdated. It's okay, don't worry about it. The second thing should be a list of all the available output ports on your computer for MIDI to send messages to. We have got the IAC driver IAC bus one. This is the one we created last time in the video. And this is the port we've selected to use messages, to send messages out to. If you have more than one thing plugged in, or you have more than one virtual bus created on your computer, you will have probably multiple options here. I only have one output option. That's this one. And so I'm able to select it. But if you have more than one, you're going to see them listed here. The order that they're listed in is important. So if you did want to use like the third item in a list, if you had 3 here, you would have to then change a number later on in the code to send the message to the right place. So you have to tell the computer to send the message to the right place. So because we only have one, and we start by indexing these lists by the number 0, so the first item is 0, we're going to use a variable equal to 0 later on in the code to actually connect the messages that this program is sending out over the ISC MIDI bus over to Helm, our synthesizer program. That's important. That's got to happen, or else your stuff's not going to work. And I'll leave this console open here so we can take a look at it. So now let's dive into the code. The code is here. We want to be looking at sketch.js. Sketch.js is the only thing you actually need to look at or possibly change. And basically this is what's going to define all of the stuff that happens in the program and sort of makes that sequencer thing work. And so there's about 800 lines of code. A lot of those are variables, and you can imagine that there's all those nodes, and they all have to sort of be addressed individually. But really what you need to think about and worry about is the top stuff. If you want to get deeper and change how the whole structure works, you totally can do that. I'm not going to go super in depth on it. I'll just sort of walk through the process and what each function does. But the things you could change and not have to worry about restructuring everything are these things at the top. So the variable MIDI select, this is the one I just mentioned. So if you have a different MIDI bus that you want to send messages to, the order that it appeared in that list over here in the console, so in this list, if you've got multiple ones, this is where you would change this. So I use the default first one, whatever the first one is, use it, and the first one is indexed by saying 0. If you want to use the second one, you would change this to number 1, etc., etc. Our next parameter here is the note on message length. So this is how long each note gets played. And so if you think about when you play piano, you press down and then you release the piano key. The note duration here is how long you've pressed and held and released the key. It's not like a drum kit where you hit it and you just go away immediately. There's some amount of time that you're holding down and pressing down. Changing this number can be fun. It can do interesting things. I've set it at 200 because it's kind of a reasonable number. If you want to do something like play an arpeggiator, though, you could have multiple keys pressed down, and you're going to want to hold them for a significant amount of time. So you might want to make this number a bit longer, a bit bigger, a bit larger. That could be something interesting you could try to do. The next thing you have here is the Midi channel. This is another one of those things that could be a reason why your stuff is not working. The Midi channel is basically we've got a bus, but then that bus has 16 channels, and so the thing that's receiving it needs to also be picked up on the right channel. So we need to be on the right bus, and we also need to be listening to the right channel. 1 is like a great default. Most programs respond to 1, so I've left it at 1. But if you did want to use it with something weird or something different, maybe you need to change that to be a different number. So often drum synthesizers, they want to listen to channel 10, for example, so you might need to change that. Theoretically, you shouldn't need to change it for what we're doing using Helm and getting the basic thing going, but sometimes this MIDI channel could be a reason why you're mismatched. So you're not sending the messages on the right channel that your synthesizer program is trying to receive on the other end. Okay, so the next two things here are limits for our probabilities. So you'll see that velocity, this is how hard or how loud the sounds are played at, is defined by a velocity value. It can range from 0 to 1, but I said I don't want it to go all the way down to 0. And you'll see that here, the diameter of the circle is defined by this value. And so at random, each time we click update, each one of the nodes gets assigned a new velocity, which is equivalent to its width. And so you can see that we've got sort of from probably about 0.25 all the way up to 1 here, values in between those two things. If you want to make it bigger than 1, I think that breaks the math in the program, but you could make it smaller than 0.25. You could make it 0, and basically it wouldn't make any sound at all. Similar thing here for our probabilities. So these probabilities are defining the probabilities of taking one of these two branches. So you can see here, you know, this one's a really thick line, this one's a really thin line. This means that more often than not, it's going to go down the thicker branch. So here we go, it's going down the thicker branch. And these probabilities are determined by these values here. So a number is picked at random between these two numbers every time. And the reason that I put a limit on these is that, let's say, for example, you got 0.99, 99% of the time. If 99% of the time you take one of the branches, it means that a whole section of the tree might get cut off and never get reached. Maybe that's something that you want and it's kind of interesting, but for me, I set a limit of 0.25 to 0.75 just so we have something interesting happening. It's not always going to go down one path or the other. It gives us a little bit more of, you know, the variability in terms of the things that happen. Okay, so our next parameter, note lengths, is defining in the map how long each of these lines is. And so the spacing and the length of those lines is going to determine the rhythm that the notes are played in, which is kind of cool. And so basically at random, every time we click update, we're going to pick one of these values for each of the line segments. Each of the line segments gets one of these values. I recommend keeping 1 as your biggest value, but then it sort of becomes a question, do you use, even divisions of 1? So this is like dividing by 4 and 2 and 3/4. So we've got sort of a constant denominator here. Doing this makes it seem like more typically musical. Putting in just a bunch of random numbers would make it seem more random. You can have as many of these as you want, as long as they're in the correct order here, and they're sort of like reasonable numbers. You could put 100, but if you put 100, basically this line is going to be 100 times longer than it is. So like this line, it's going to be off the page and you're going to have to wait a long time. But again, maybe that's kind of cool and interesting. So I recommend sticking with 1 as your biggest, but you don't have to. The next parameter here is controlling the clock speed. So if you see, how all these dots are being drawn, basically there's, a certain amount of time between each dot. So from dot to dot, there's a certain amount of time that passes. And we can see that in shorter segments, we have less dots, and in longer segments, we have more dots. That kind of thing is happening. This is defined in sort of milliseconds. There's this thing called a clock tick. There's 30 milliseconds per clock tick right now. The long and short of this, though, is if you want your thing to go faster, make this number smaller. If you want to go slower, make this number bigger. So the next number we have here is our fundamental. This is the root note. This is like the basis for all of our scales and the starting point for our music. And so this number that you pick, 60, is a representation of a piano keyboard sort of numbered from 0 to 127. So the possible values here that are allowed are 0 to 127, and 60 is sort of somewhere in the middle. 60 represents sort of middle C on a piano. 0 would represent like not even on a normal piano, so like below a piano, and 127 again is way above a piano. But in that range, you've got all the keys, and they're sort of numbered numerically. So 60 is C, 61 is C sharp, 62 is D, etc., etc. We next have an array. So picking this, before I go on to the next thing, picking this, what it's going to do is sort of provide an anchor for your music. So you'll see that every time I click update, this thing is the same color. Again, the color is mapped to the pitch. So I click update, you can see that this one here, it never changes size or it never changes color. It's always going to be the fundamental value, whatever that fundamental is. And it's always going to be, this constant anchor for the music. So once we get to listening to it a bit more, you'll sort of hear this note, this root, being played repeatedly, consistently throughout the sound. That's intentional. So we have this basis, this sort of like this root, this anchor that we're going to then connect our scales and ideas to on top of. Okay, so there we go, our fundamental. So you could change this. A lower number here again just makes that fundamental lower, so that the notes will be around that will be a bit lower that you played. And if you make it higher, then you get higher notes. The last thing that you sort of have access to mess with is the scale here. And so this is basically taking our fundamental, so 60, so middle C on a piano, and it's saying, okay, 0 plus 60 is middle C. 60 plus 2, go over C, D. 60 plus 3, you just keep going and keep going and keep going. And basically, this is how far you're moving over from that fundamental. So 60 plus a couple keys over, 60 plus 3 keys over, 60 plus 5 keys over, 60 plus 7 keys over, etc., etc. And 60 plus 12 keys would give us our full octave. So it would be like C to C, representing that. In the code base, I actually represent 2 full octaves, so I go from like C to C to C, so 3 Cs, or 3 whatever your fundamental notes are. But we only set one set of notes and one set of scale notes here. So here they are. That's great. They're really nice, sort of even numbers here. There's a whole bunch of different scales you can include, and if you want to change out like the sort of the feeling and mood of your music, all you need to do is copy one of these scales. So I copied it, and then I could paste it in here and replace it. And what that's going to do is change the notes in the set of notes that we're going to pick out from random to actually sort of determine what each of these notes pitches are. So again, another parameter gets set here is whenever you click update, it's going to go pick a note at random from that scale and that set of notes that you've created for it. Okay. So we've got then a bunch of variables, lots of variables. The rest of this stuff you really shouldn't change unless you're like into really messing with this. And if you're into really messing with this, I love it. And like get to it. But if you're gonna do, if you're just dipping your toe in, this is where you should stop. So don't do anything past line 38, or you could mess it up. You could still mess it up above line 38 too, but follow those guidelines I have for stuff, and it should be all okay. Okay, so what is this rest of this stuff doing? Well, we've got some variables here. So these are, basically the variables that we use to describe all of these nodes and lines and things like that. Similarly, our location variables, all that kind of stuff. We're going to create like a variable for our button. So having this allows us to have a button. We've got a MIDI output, so we need a variable for that. We've got some scaling and drawing stuff that help us draw things. We've got a path variable, sort of define the path each time it goes through. And that's all we've got. So we've got a whole bunch of variables that we're going to use throughout the program. We then go into our next thing. This is our setup function. So this is sort of the typical structure of a processing or a P5.js script, is that you set up a bunch of variables. These are our global variables that we want to use throughout the entire program. Above, our first function that we define is usually our setup function. This function will run once when we load the program, so when we refresh our website. And it's doing a couple of basic things. So it creates a canvas, a 900 by 500 canvas. This canvas size is 900 by 500. It draws the background a color. In this case, it's a grayscale color of 210 value. So the background gray here is like 210. That number goes from 0 to 255. We set up a fill value of 0 here. We do a thing called calculate the notes. So we figure out which notes we're going to play. We're going to initialize our parameters. So we're going to figure out like the lengths of all the lines and the probabilities and the thicknesses of all the lines. We're going to figure out where the locations are so we can draw everything. We're going to set up some text stuff. We're going to set this clock speed, so how often we're going to do that clock tick thing that we saw before. And then we're going to create a button, and this is our update button. This code runs once, the program's ready to go. We come in and we draw our beat here in our main draw function. So let's get rid of the setup function. I'm just going to minimize it here. That was just like a code thing. It's an atom. Your processing, your text editor might not have that feature. But the draw beat is our next big thing. This is a function that just loops over and over and over and over and over. And so basically, we're just saying loop, 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 loop. And as we're doing this, draw the beat to the screen and just keep doing that as you go. The next thing here is an update map function. So whenever I click the update button, I'm saying initialize all the parameters again, calculate new locations, calculate new paths, and draw all the branches to the screen. That's what that function does. We've got a calculate notes function. So this is taking our scales and turning into the notes that we want to use. We've got a calculate locations function. So this is figuring out where all the locations of the things are, given all our probabilities and lengths and line lengths and all those kinds of stuff. We've got an initialize parameter function that we called. So this is again figuring out what each of those things has as value. So this is saying, okay, pick from the possible set of notes, add the fundamental value, and the note N11, this one right here, its value is going to be determined as a random selection of the possible notes plus the fundamental note. The velocity is being a random value between the lowest velocity level we defined earlier and the highest velocity level. The probability of taking one of the paths, again, the lowest to the highest. And then the length of each section is one of the values of that note lengths array that we defined much earlier, sort of thing. And so you got to go through that for all of them. There's a whole bunch there. And so we've got that one. So that's the initialize parameters function. Let's get rid of this one. We've got a metro function. This is the clock tick thing. And so basically it's going through and checking if we've passed certain points. If we have, we'll send MIDI notes. And if we're sort of a certain length along the path, we'll send these MIDI notes out. And we'll just sort of keep running this function every sort of a certain amount of time that happens. We're going to draw the beat to the screen, so drawing all those circles on there. So this is a function that does all of those, drawing those circle things to the screen. Let's close that one. We're going to calculate the path each time we go through the loop. So we're going to figure out which way we're going, which paths we're taking. We're going to draw different colors to the screen, so there's a function for that. We're going to draw all the branches to the screen, so the background stuff will draw to the screen, so there's a function that does that. Then we're going to send the MIDI notes out. There's a function that sends MIDI notes. And then there's a function that sets up the web MIDI thing. So basically setting up that MIDI bus and the connection between the program and your computer. Okay, 800 lines of code, very quickly gone through. Again, all these functions, there's some good commenting for everything, but really you don't need to mess with these unless you're interested in messing with them. If you are interested in messing with them, that's totally cool. But the stuff you need to change is all things that are above basically line 38 here. So line 38 and above are the easy things you can change. So if you do make changes here, you need to refresh your web page by clicking Command R. Doing that changes and updates the code, reruns the code, and sort of make things reload and updates to the file you saved here. So if you make changes, save the file, go back to your web browser, click reloads. You can click reload up here, or you can click Command R and reload the page. That'll refresh the script and refresh the thing that you're using. And hopefully all this worked. So hopefully this worked. Hopefully this worked. Hopefully this worked. Please, I hope it worked. So in the next video, I'm going to talk a little bit about how to sort of now use this in a performative sense and make some music with it. So I'm going to demo making music with it. Yeah, it should be fun. If none of this code worked though, I wanted to refresh you again. If none of the code worked, you should be able to go back to the website where the tutorial's sort of hosted from. There is an online version of this. Click here. Hopefully if you set up your MIDI bus correctly, this thing is listing the right thing that you're going to want to connect to your synthesizer program. So again, going over to here, the big thing you need to have to make this work is that this name that's listed here has to match this name that's listed here. So the output that we're using for our MIDI bus has to match the input that we're expecting on our synthesizer. If those two things match, and you're seeing these sort of keys light up and things happen, then you should be good to go to the next video. The next video, I'm going to talk about how we actually make this thing into something musical. Okay, so that's it. Just stay tuned for the next video and check out the music and sounds we're going to make here.